All right, let's get started. So I just want to give a quick roadmap of where we're at with homework 1. We just learned about Docker and Docker Compose. So we can satisfy this part. You have to use Docker and Docker Compose for every homework, including homework 1, including this one. You have to have this configuration set up exactly. Having your Docker Compose, you should be able to run Docker Compose up, and your app should be running on port 8080. You should be able to go to your browser, go to 8080, and be able to access your site. And I strongly recommend, in bold even, I strongly recommend that you check your Docker configuration after you submit. So what I recommend is submit your final submission. I'm done with this code. I tested everything. I'm happy with it. Submit to Autolab. Submit your zip file to Autolab with all your code. Then download that zip file into a fresh directory with nothing in it. Unzip it. Run Docker Compose up. Go to your browser and go to port 8080, localhost port 8080, because that's exactly what the TAs are going to do. They get your zip file, they unzip it, they run Docker Compose up, and they go to the browser to start testing your app. I recommend you do that exactly. And if Docker Compose, if you have any issues with anything in Docker, and you say, well, my app works perfect if you run it with Python, but not with Docker Compose, or works good with Docker, but not Docker Compose, or whatever, we might be a little lenient on homework 1, to be honest, but we may limit your objective grades to 1 out of 3 for all the objectives. Even if you have a perfect submission, perfect server, if there's a Docker Compose issue, we're not going to have tolerance on that, again, with the exception of maybe some tolerance on homework 1, that you won't be able to get good grades in the course if you have a Docker Compose issue. So if Docker Compose is running on port 8081 in your submission, for example, it's a really silly thing to lose points for. Please, please, please double check that. The amount of students, which isn't a lot, but it's more than 0, the amount of students who come to me and say, oh, I submitted and I got 1s on all my objectives because I submitted with the wrong Docker Compose file. Please do this. Please actually do this and test your code. Make sure you didn't submit with the wrong configuration. Because it's common to have a different configuration when you're testing locally than what you're actually submitting. So make sure what you're submitting is following the homework guidelines. Make sure you're submitting an appropriate submission with the appropriate setup and configuration. Yeah.
Is it okay if the Docker file and the Docker Compose file both expose port 8080? Will that cause? I do that in my
No.
code and it runs fine.
Yeah, that should be fine. So if you're mapping 8080 to 8080?
8080 to 8000, like it says.
But you're exposing both 8000 and 8080 inside the container?
8080, like if I do localhost 8080, everything works.
Yeah.
I don't know how to describe it. I set it up like a week or 2 ago, and I've just been.
I mean, if it follows the testing procedure and works fine, I'm okay with it. It sounds like it should. But even if you map 8080 to 8080, that still works. Everything's fine with that as well.
No, I think I mapped it to whatever it says in the examples and stuff.
Okay. Yeah, I'm not exactly sure what you mean, but if it is working, it should be fine. Okay. But please test this after submitting, because it is common to have 2 different configurations. You're configuring testing locally, and then for submission, it's a different Docker Compose file sometimes. Make sure you submit with the right Docker Compose when I have students with that problem, because I mean, I'll be strict on it, but I still feel bad. Like, you did all the work, you learned what you're supposed to learn, except for the Docker content. Which is a big part of this course. Part of this course is learning Docker and Docker Compose. So I'll feel bad. And on homework 1, I'm more tempted to say, okay, let me actually grade your server based on the mistake you told me about. Let me fix that, as long as you can explain your mistake, and then grade it. Homework 2 and onward, I'll have much less sympathy. We got to get beyond the Docker and Docker Compose issues, especially since I gave you the sample Docker Compose, and you just have to copy them from the slides. It's not that hard, but you have to understand how Docker is working. Installing Docker can be a pain sometimes, especially on Windows, but you got to go through that. Yeah.
Is Docker like an industry tool that's like used in the industry, or is it,
Oh, yeah.
is it mostly like an independent developer thing?
You'll use Docker in industry, like almost guaranteed. Docker just blew up and took over the industry. There's some competition, other ways of doing containerization that has some competition there, but if you're in industry and you're not using containers, like you're getting left behind at this point. Containers are the thing now. It very quickly happened too. Like I heard Docker for the first time, and then I feel like the next day, like everyone was using Docker. It was crazy how fast it took over, because it really does solve this problem of dev environment, prod environment. It just solves that so well that industry, all across industry, they realized that and just blew up. Which is part of why, going into what I was just saying, goes into why I want you to learn Docker in this course. I probably give you a little too much, so you don't learn it all together well, but at least getting used to this running containers, getting used to that idea, because you'll see it again, almost guaranteed. Treat recommendations like warning, ignore it. Don't take that advice. I recommend that you don't take that advice, I guess. So if you're taking that advice, you're not going to listen. But yeah, and feel free to ask people in the industry. If anybody contradicts what I just said, I'd love to hear about it, what they're using. But from what I can see, from people I talk to, it's containers all the way. Most of it's Docker. Okay, roadmap of the homework. Objective 1, we could do this for a while, and now that you know how to do Docker and Docker Compose, you can do this to the point where you're earning credit for it when you on your homework. Have this running in Docker Compose, good to go. This is just running a few paths, one that returns hello, just the hello world of this course, one that returns a redirect, and one that returns a 404, the else 404. The 404, yeah, the way I wrote it, yeah, oh, I did write it. I did have it there. So for the 404, as we add more features to your site, like obviously that overrules some of the 404. Like the root path shouldn't return a 404 after you're done with Objective 2. So anything that's not defined by this assignment, and we're not going to test the 404 with /image/users, which are Objectives 3, 4, and 5. We're not going to test those, so you don't have to check the paths for those ones, for errors.
So we should make a different server for every objective. It should be all.
It's one server. One server for all 5 objectives. So, and what most of your servers will look like is perfectly fine. I'll talk about this in more depth after homework 1. But what most of your servers will look like is read from the TCP stream, convert it to a string, at least for homework 1, it'll look like this. Convert it to a string, parse the values, and then say if path equals this and method, HTTP method equals this, then return this. Else if path and method equal this, do this. Else if, else if, else if, else if, else if, else if, and then else 404. That's what most of your code will look like. So you have one server that's going to check the incoming request, check what's being requested, and then return with the appropriate response based on that request. But one server is going to handle all 5 objectives. So if you have a big else if, else if, else if, else if block in your code, or in Python, elif, 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 if you have that in your code, you're probably on the right track. I'll leave this as a challenge for now, but writing that without the else if, bunch of else ifs, if you're looking for a deeper challenge in the course, try it. There are ways to do it. There are fun ways to do it. But I made the mistake of talking about that too early last semester. I'm not going to do that again. I said it too early and it confused everybody. So Objective 2, hosting a static site. This is not too much of a jump from Objective 1. But hosting HTML, CSS, and JavaScript from the sample site that's provided in the zip file, which is linked at the top of this objective, or make your own front end. I don't want to focus on front end in this course, so asking you to host front end, I just gave you a honestly pretty crappy site that I made just to have something for this homework assignment. But host those files if you don't want to make your own. If you agree that that site's crappy and you want to do something about it, feel free to make your own front end. The TAs and I, we love seeing the really nice, well thought out front ends when you're doing this objective. We like grading those. So if you don't like mine, make your own, and I'd love to see it. Hosting these, you're reading the file, taking the contents of the file, that's the body of your response, and making sure you get the appropriate content length and content type of that response. Setting your right MIME types using UTF-8. There are emojis in both the HTML and the JavaScript, so getting the right encodings to make sure that that UTF-8 is sent and interpreted properly, as we talked about in previous lectures, is going to be part of this objective. Hosting images. Again, with images, don't overthink it. It's very similar to the previous objective, but the data of that image can never be converted to a string. It's an image, it's not text, it's not a string, it's not encoded using ASCII or UTF-8 or any other text encoding. It will not decode properly. It will break, it will corrupt the file. So the big thing here is just making sure your image bytes stay bytes. Other than that, it's really the same as the other objectives. You have options for how to host the images. I mentioned this last time, somebody asked about it. But if you just want to hard code each of the images, we will test with the exact images from the sample site. So if you want to hard code each one of those images for homework 1, that's fine. We'll start doing more things with pathing. I'll have you do more things with pathing later on this semester. If you want to read this dynamically too, it's just a little more programming. It's not too much difficult, but it doesn't really have anything to do with the content of this course per se, so I'm not too concerned if you hard code this one. You'll have plenty of time to read paths, starting with objective 5, actually. So hosting images, and what we want to talk about today is the next 2 images. We're going to, bless you, the next 2 objectives. We're going to talk about how to do objectives 4 and 5 today, and Friday will just be examples. That'll be the end of homework 1 content, and then I'll move on to homework 2 content, which, by the way, this section of the course is related to homework 1. I think I mentioned this day 1, but just in case I haven't, plus that was 3 weeks ago. This is all the homework 1 content. 3 weeks of homework 1 content. Once we start dynamic sites, I'll post homework 2 right here, which I want to post pretty soon here. I want to get that one out. This is all homework 2 content. So Friday is the last day of homework 1 content. Today is actually the last day of content that you need, and then Friday's examples, just reinforcing things, showing you some things. I intend to break an image and play around with Docker and stuff like that. I'll show you Postman as well. It's a fun lecture. I like it. But what am I doing? Homework 1. But let's learn how to build this RESTful API. So you're going to create an API which is going to allow users to create a user, which is going to be defined by an email and username. They're going to be able to ask, hey, tell me what the users are that were created. Give me a specific user where you have to read the ID of the user from the path of the URL. Update a user by ID and change either the username, email, or both. And delete a user so they don't show up in any queries after they are deleted. So that's what we want to build today. And all of this has to be supported by a database. That's why we talked about Docker Compose with databases last time. All this data has to be stored in a database. And again, a reminder, the point breakdown of the homeworks, the first 2 objectives, each homework is going to have the same breakdown. The first 2 objectives are like the core concepts. That's what I really want you to get out of this section of the course. 60 points for those ones. The objective 3 is going to expand on that a bit. That's where you can get up to 80% if you understand that. That's like understanding what we did in lecture and what we talked about, etc. And then objectives 4 and 5 will be like add-on features. You can add an extra feature using what we learned and using it in a little bit more creative way, but not necessarily core and fundamental to what I really need you to get out of the course. And that's where you're earning your A, getting those last 20 points. All right, any questions on that before I get into some more slides? Big Yoshi was awesome. freedom that will lead to regretting the freedom? You mean creating your own front ends? I'd be impressed if you showed me a front end that I regretted seeing. I've seen some wacky front ends before, and I ain't regretting one yet. I like it. All right, so let's learn about APIs. Geez, we're 17 minutes in. I talked too much about the homework. Yeah, take that as a challenge if you want. When will the team formation form be activated? Soon. I got to get all the project stuff ready and release homework 2. Those are on my to-do list, short term. All right, so we're going to have data that we're going to store in a database. How do we do that? How do we handle data? And specifically, how do we let users handle data? So for objectives 4 and 5, users are going to be sending HTTP requests, which are going to be modifying data in our database. How are we going to do that? So our users can only interact with our server, and only our server can interact with our database. We're not going to give our users direct access to the database for a multitude of reasons. 1, they're going to break stuff, even unintentionally. But 2, privacy. Like, you have 0 privacy at that point. We're not giving them access to the database. Server can access the database. The users can only access our server. So how are we going to do data? What do we do? How do we do this? So let's start with the server talking to the database and how we're going to access that data. Now, this is one of those things where there's like a billion different answers for it. I'm going to show you a very common model out there. This is used in industry quite a bit, called CRUD. So we're going to only allow 4 basic operations on our data. And this is just a good rule of thumb to follow, and it's followed a lot out there, is when you're accessing your database, you don't want to do complex operations. Your database operations should be very simple. This should be what we call atomic, very simple, small operations. You don't want a method that's going to update like half your database and do all kinds of complex stuff, create all kinds of rows and columns and stuff. We don't like that. So to avoid that, we stick to these 4 basic operations: create, retrieve, update, delete. Just allow those things on one specific entity of a database. So if I have the users table, for example, and I'll use terminology based on SQL, I don't know, I'm used to saying tables. But if I have one table for my users, for my API in objectives 4 and 5, I'm only going to allow these 4 operations on user data, and I'm only going to allow these operations on one piece of data at a time, on one user at a time. If I allow more than that, say create a user and also create a shopping cart for them and preload that shopping cart with the item that they just added, if I allow all that in one operation, things start getting really messy, hard to debug, hard to manage your data. It gets more difficult to do things. If you stick with these 4 operations, things stay simpler, easier to debug, easier to manage, easier to add features, expand features. If you're not following these, it gets tough to maintain the code. Add features, modify features, fix bugs, all that stuff. Break the cord law. I don't think that's why I'm getting pinged. Let's ping Jesse. Retrieve. There's a challenge. I don't think I'm getting pinged for any reason, right? I'm just being impersonated. So let's go through these one at a time. Create. They're all self-explanatory from the names, but I want to go into a little bit of detail on each one of them. Create, we're going to create a new record. Create a new user for our API in homework 1. And I'll give examples in SQL and MongoDB, but I'll give them language independent, just the query language examples. I'm not going to show you the wrapper with how to do them in a language. That's up to you to figure out, because I'm not going to do every language. Create a new record, insert into in SQL, and .insert in, I almost said Python, in MongoDB. Yeah? Oh, right. Yeah, I should update my slides. Insert _1 in Python. I believe insert does still exist. I'll try to bail myself out here. I believe insert still exists in MongoDB itself, but not in the Python library, PyMongo. It drives me nuts that they changed that they removed the insert method. Like, why not have the simplest name? Just have insert call insert one. I don't know why that's so complicated. Yeah.
Some people in the chat are asking if you can turn up your mic.
Turn up? Oh, yeah, absolutely. The system works. All right. Better if they say it again, let me know again. Yes, that's what you're saying? Okay, cool. All right. Yeah, I turned it down at the beginning, but I guess I turned it down a little too much. From down here, I hear an echo, and it bugs me. So if I turn it down too much at all, always please. I had a section, a course that doesn't exist anymore, 113, Intro to CS for non-majors. It was in this room even, and at the end of the semester, the course evals at the end of the semester, like a bunch of them said, I couldn't even hear him all semester. Like, I wish he turned up his mic. Like, tell me that when it matters. You could have told me that at any time. I'll happily turn this thing up. I'll crank this up to max if you want me to. But don't wait till the course evals to tell me something like that. So please, thank you whoever said it in chat. Please let me know that stuff. I want to fix those issues. Please. So insert into a database. When we insert, a new record should be created. So we're going to add a new record into our database, a new row into our table, or a new document in our collection. We're going to add that record into our database, and we want to create an ID for that record. These should typically be integer values that auto-increment starting at 0 or 1. However you want to do that. In the homework, it has to be a unique integer for each record. So however you want to do that is up to you how to get it done. But we need a unique ID for each value in the database. So we're going to give them values, assign them IDs, enter that record into the database with the username, email, and the ID that we generated or that you generated in your homework assignment. If your database has an auto-increment feature, for example, if you're using SQL, just put auto-increment on that table, and it'll give it ID starting at 1, and then increment it each time a new record is created, and it'll just handle that for you. MongoDB, we're not so lucky. MongoDB doesn't have an auto-increment feature, so we do have to think about this one a little bit more if you're using MongoDB. So MongoDB, no auto-increment. What I recommend is kind of what you have to do, actually. I don't know what alternate solution there would be for this. But what I recommend is creating a separate collection that's going to store the previously used ID. Read from that collection, get the previously used ID, bump it up by 1. That's the ID of your new record. And then update that collection that only stores 1 value. Update that collection with the new, latest incremented value. That way you can build this auto-increment feature in your code. That has to be in your database. You can't store a variable in memory. You can't just have a local variable that's going to handle that, or even a global variable. Wouldn't do the trick. Because when we restart your server and add another record, it needs to not get ID 1 because there's probably already an ID 1 record in there. So these IDs have to be unique. As long as you can get them to be unique, I don't care how you do it, but don't use _ID. When you start using MongoDB, every single record is going to automatically get an _ID value. That value can't be used for the homework assignment, primarily because it's not an int, but also because I want you to think about how your database is working and not just use that value. So, but if you're using MySQL, I guess you have auto increment, but you also have to deal with MySQL. So I'm fine with that trade-off. Yeah.
What is how do you disable the default ID feature?
How you disable? Oh, so those will be there. They'll still exist. Just don't return them from your API.
Oh.
Don't give them to the end user. They'll always exist, though. Filter those out, though. Like the API, somebody consuming your API, they shouldn't know or care what type of database you use on the back end. They certainly don't want to see those underscore IDs. They don't want to see any database-specific stuff. They just want the data as defined in the homework doc. Right, retrieve and list. Retrieve in the acronym. This is actually list. Select, give me everything in this API. So for our purposes, this is give me every user in the database, just send them all my way, unless they've been deleted. Send them all my way. Select star or find empty key value store. This is usually called list, which means the acronym is actually CRUDL when list operations are allowed, when that exists. So technically the homework API is a CRUDL, has CRUDL operations, but I think CRUDL sounds kind of dumb, and I like saying CRUD. That's the only reason I'm going to call it CRUD. So whatever. If you hear CRUDL in the future, just know that that is what you learned in this course. Yeah.
The Mongo one returns everything that they have in the whole database. What is the SQL one return?
The same thing. Everything. This returns everything in the user table. This returns everything in the user collection.
So user is just the name of this one table.
Yeah. Mm-hmm. And this is assuming that we already pulled a collection called users or whatever from the database. In this user collection, I'm grabbing everything from just that collection. So you wouldn't, like if you have a separate collection for the auto-incrementing stuff, you wouldn't get that data from this query. Yeah, why not CRUDL? I just think it sounds like no other reason. I think that's fairly common. People say CRUD when it's CRUDL. I think a lot of people agree with me on that one. But if you hear CRUDL, you know what's going on. All right, retrieve. This is retrieving a single record. So we're going to have some filtering based on the ID. We're going to retrieve a record by ID. This is why every record needs a unique ID, because when we want to retrieve a specific record, we're going to retrieve it by ID. Give me the record with ID 3, find the record with ID 3. That's our retrieve method. And update, which I didn't show examples of last time when we were talking about databases, but update an existing record that already exists. So set email and username with an ID, or update with this syntax for MongoDB. You're going to give it a filter for MongoDB, a filter just like find. We're going to find every record with an ID of 5, which there should only be one, should be just a unique value because our ID should be unique. And then the second argument is going to be what to update. MongoDB has a lot of commands like this where you do $ and then the command. And then that command is going to tell MongoDB what to do with the records it finds. So for every record with ID 5, set email to this and username to this, whatever the user supplied.
Isn't it supposed to be quotation marks around the 5, or is that because it's already valid JSON you don't need it because it's supposed to be a number?
Mm-hmm. Yeah, 5 is an int. So it has to be given as an int. If you put quotes around it and you're storing them as ints, it's not going to do what we want. You can update for our homework. Oh, that's what I was saying. For the homework assignment, to update a record, a user is going to have to provide both email and username. So don't worry about somebody who just wants to update their username or just their email. They'll give you both pieces of information, and then you'll update both of them, even if one of them happens to be the same as what it used to be. That's fine. Just to keep things a little bit simpler, and that is somewhat common in practice as well. You're just going to give it the whole new record except for the ID. So the ID is how we're identifying that record forever. These IDs can't change, because if an ID changes, how do people know how to find that record again? If I have a user ID for a specific service, and my user ID changes, like how am I going to access anything? How do I know about that? Yeah.
Do we put it to
if something exists other than those. So for the homework, it won't be the case. But to answer the question, in SQL, I think it would be fine. I don't think that would do anything, but I think it'd be fine in both of these. Yeah, it'd be fine in both of these because when we update like this, it doesn't get rid of the ID. Like the ID still remains. So this would just update the fields that we give it. Yeah.
Is there an inbuilt method in Mongo for like selecting the largest example, or do you have to do that in the server?
I don't know off the top of my head.
Okay.
I would just do it in the server, but I don't know if there's a more efficient way to do it at the database level. There might be. In MongoDB, you said, right? Because SQL can do that. SQL is really powerful. It has all kinds of stuff to do. I don't think MongoDB has such a thing, but it might, and I might just not be remembering. Right? Did you ask about SQL or MongoDB?
What's the behavior of delete? Should we also give her the associated ID, or should we just keep incrementing it?
You should keep incrementing it. So you don't want to delete a record and then reuse that ID, because then it would be as though that user just changed their username and email. And somebody looking for that ID would actually get data, but it wouldn't be what they were looking for. Like if you delete a post and then you reuse the ID, now that post is just replaced with somebody else's text. Like you don't want that feature. That ID is retired. The ID, so don't change the ID ever. The ID can change, like it's physically possible. You can go into the database and change IDs. Just don't. It's a bad idea. And especially those IDs will be used by other records to reference that record. It just breaks everything. And finally, delete. Delete from, where, and then delete, and then give it a filter. So this deletes every record with ID 2. For our purposes, this should only be a single record. And same here. This should only delete one single record. As long as you're maintaining your IDs properly and you do give them unique integers, this is only going to delete the record with value 2. Or if there is no record with value 2, it just doesn't delete anything. And everything's fine. Yeah.
With ID and MongoDB, since we are maintaining ourselves and having we're keep track of the integer, is the key ID equal to the key email or username, and then they're both just kind of I don't know, it doesn't have any special properties itself. We just treat it as a special thing.
For the ID in the second collection that I was mentioning, would that have?
Yes.
Or the IDs for the users too? Like none of those are special. We just treat them as special in our code. Yeah. That's why you were asking about the max, because you don't want to have that separate collection. You just want to find the max ID. But if the max ID was deleted, is that where your line of thought is?
No, I was just wondering, the easiest way of finding, what you need to make the next ID for. The easiest way of access.
Yeah. Yeah, so you want to get the max ID, but if the record with the max ID was deleted, then you would have reusing an ID, so you would get in trouble with that one. Unless you use soft deletes. So it's very rare, or at least it should be very rare, for anything to actually be deleted. Personally, I don't like deleting anything ever. It's just partly paranoia, but what if I need that data at some point? So it's common to soft delete data. So instead of actually deleting it, you mark it as deleted and then don't serve that data, never access that data anymore. So you would update your filters, like when somebody's retrieving all of the records from the database, instead of saying select star from this table, just give everything, you would say select star where deleted equals false, or however you want your flag set up. Deleted doesn't exist, deleted is null, however you want to figure out how to do that, if you want to use soft deletes. If you use soft deletes, then you can do your max thing, and then the highest value ID record will still be there, it'll just be marked as deleted. And then if somebody tries to retrieve something marked as deleted, hit them with the 404, say, I don't know what you're talking about. Don't tell them that data is still there. It's common to soft delete. One big thing, a user's like, oh man, I accidentally deleted something that's super important to me. You can just go in, flip that bit, and it's undeleted. It's back. It's there. And we always like to preserve history. I want to know what happened. Something breaks. The user has a really obscure bug or something. I want to know what that user did so I can recreate that bug and fix it. If it's because they deleted something, and that's part of the puzzle for my debug process, they deleted something and I straight up deleted it from the database, I don't know what to do at that point. But if it's deleted, I marked it as deleted, and I can see the whole picture of what happened, it's going to be easier to debug things. Yeah.
So if you wanted to store like voter records, you might have, oh, here's the name, here's the age, birth date, and then you'd also have deleted if you wanted to do a soft delete.
Yeah, you'd have, so for SQL, you would create another column to your table of deleted. Okay, so that's how our server is going to talk to the database. We're going to use our CRUD operations and keep things simple. Just stick to those 4 or technically 5 operations. I like to just say list is retrieve, and then I can get away with my different acronym. But how do the users talk to our server? Let's take a look at the other side. And of course, HTTP, baby. We're going to use get, post, put, and delete. These will be the HTTP methods that we'll use for our API. Let's talk about each one of these. We saw get and post. We want to introduce put and delete and talk about these in a little bit more depth. So put is going to be used to create or update records, which your first question should be, why? Like, why not just use post? Like, why are we using put? So the difference between post and put is that post is going to require the server to process the data, process the request in some way. In our case, it's generating the ID for the record that's being created. That's something that the server has to do, which means it must be labeled as a post, or should be labeled as a post request. Put is giving the user more direct access. The server doesn't have to process anything. The user is, it might have some processing, but it's not going to like create information like an ID. Server doesn't process the request, and it must be idempotent. And I want to give my disclaimer right here. These words aren't magical. Post, put, delete, get. Like, you could have your API have a delete method that actually creates records. Like, you could code that. You have the physical ability to do that. These words, these methods are made to communicate between other developers and your users, and it's more of a contract. Like, if you say this path of my API is a put request, that's communicating to everybody that that's an idempotent request that doesn't require the server to process anything. If you have a post request, you're saying, look, I'm going to process something after you submit that. It's a way to communicate to other people, other humans, what your endpoints are supposed to be doing, how they're supposed to behave. If you have a GET request, you expect nobody to send any information in a body of the request, and you're just retrieving information. Idempotent, what does that mean? It means that if you send multiple requests, multiple identical requests, it should have the same effect as sending that request one time. Additional identical requests should not have additional effect on the state of the server. This is idempotent. So if you label something as put or delete is also idempotent, it can't change the state of I misspoke a little bit. Not the state of the server, but the state of the API. So if I make multiple put requests that are identical, have identical content, that shouldn't change anything with the API. If I retrieve information from the API after that, it should all be the same information as it was after the first put request. Yeah.
On the previous slide, you said the put request could create or update a record.
Mm-hmm.
And I was kind of confused. If you are creating a record, wouldn't you require the server process the data?
So that's why our creating records is a post request. If the users were, in our case, if the users were in charge of their own IDs, then we could use a put request for creation. We could say, okay, I'm going to create a record with ID 5 with this email and this username. And then if they send that again, we'll be like, oh, we already have a record labeled 5. You must be replacing that with this information. It happens to be replaced with the same information and no change change happen. Our post is not idempotent because if we created 2 records with our post request, we're going to get 2 records with 2 different IDs. So post is not that endpoint of our API is not idempotent, so we have to label that as post instead of put. Yep. So update is a put request in our API. If you update the same record multiple times with the same data, the subsequent requests don't have any effect. You already changed your username and email. Changing it again to the same values isn't going to have any effect on the API. So that's idempotent, and we can safely label our update as a put request. Get is just by its nature idempotent, at least in APIs. You might have GET requests that are not idempotent. For example, if you have a view counter on your website, multiple GET requests are going to change the state of what's returned. But for our API, retrieving values from an API shouldn't be changing the state of the API. If it is, you're violating idempotency. Put and delete R, I mentioned that a few times. Post is not, I got ahead of my slide here too. Post is not idempotent. 2 post requests to create in our API are going to create multiple records with different IDs. The server is processing the sent information, generating the ID, and then storing a new record with that ID, not idempotent. So we're going to label that as post. Finally, RESTful API. Oh boy. RESTful API is one of those, one of those things, I guess. So RESTful API is kind of loosely defined. It is strongly defined, but it's a little controversial. It's a little debatable. There is no RFC for REST, but it's something you're going to hear like all the time out there. You're going to hear RESTful API constantly. It is strongly defined, but I think it's pretty loosely understood. It's a very strict definition that most APIs that are called RESTful APIs are not, strictly speaking and technically speaking, RESTful APIs, including the one on the homework. The one on the homework isn't, strictly speaking, a RESTful API, but I'm going to call it a RESTful API because everybody else does it. We typically, the way RESTful is defined in practice is something can be more or less RESTful. This is like the vocab that developers use. You can have an API that's, that API is more RESTful than another API. If we make this change, we'll make our API more RESTful. And if you're in a meeting and you're developing an API, you're designing an API, and somebody makes a suggestion that's clearly not following RESTful practices, somebody else is going to say, that's not very RESTful. Like that's how it's used in dialogue, in regular conversations. But there is a specific definition of a RESTful API, which is an API with certain constraints. One, it's a client-server architecture with statelessness. Can't have any state. This is the first controversial one right from jump here. We have a client-server architecture. For HTTP, this is implied. HTTP is client-server, and it's stateless. So we kind of have this one by default, unless we start using cookies. Unless we start using cookies, which is going to make the API no longer stateless. Cookies are a way of simulating state in a stateless protocol. So cookies would make something not stateless. So if you have something like an API token to access your API, which if you've accessed any API, it probably required a token. It's strictly speaking not RESTful, but who cares? Like we want to use API tokens. We want to authenticate users. We want to do these things. So technically not RESTful, but you're going to see anything labeled a RESTful API usually will have an API token, and you'll see debates online. You can have fun reading them. I have fun reading them from time to time of people arguing, well, the API token isn't RESTful, so because it's not stateless. You have state, which is the token, and it gets more involved than anybody in this room probably cares. Or you might want to have those debates. But I'm letting you know that debate exists. I'm not going to take a stance on. Well, actually, I am taking a stance because I'm calling the homework API RESTful. So the API should have all cacheability information. The homework API doesn't have any cacheability, so I'm violating this one as well. But a true RESTful API should have all the information about how to cache everything. I guess the homework API does, because it just doesn't contain any, it just can't be cached at all. It should be a layered system, so if you put a layer in between your client and your server, that layer shouldn't affect the behavior of the API. So if you want, say, a load balancer or a proxy server adding HTTPS doing encryption, adding that layer shouldn't affect the behavior. Like, for example, your server shouldn't be relying on the IP and port address of your end client, because that might be obscured through a proxy server. You might not even have access to that information, because you might be talking to a proxy or a load balancer or something. You can't be relying on any information other than the request itself. That's the only thing you have to work with when you have a RESTful API. There should be a uniform interface, meaning all the data should be self-contained in the API itself. This one's a little bit violated because you need, in our homework, because you need the homework doc to understand the endpoints instead of having a root path which returns the documentation. But other than that, we pretty much got this. We're always returning all of the information. You create a new record, and what's returned is that whole record that was created, including its ID. So you have all the information self-contained in the API. So when a user talks to us, it's going to use RESTful API using HTTP requests. Then when the server talks to the database, we're going to use those CRUD operations, translate those RESTful API requests to CRUD operations, and then talk to the database that way. And I went a little long this time. Oh, well, it depends on what clock I look at. 49, 50, 49, 48. I don't know what time it is. 49 on my laptop. I'm going to go with that one. Oh, and if you want to know more about databases, Oliver's teaching 250 right after this. He knows the hell out of databases. So if you got questions, hit him up. And see you everyone Friday.